Hello students, welcome back to the channel. Today our topic is power in an AC circuit. In a DC circuit, power is simply voltage times current. But in an AC circuit, things get a little more interesting. Why? Because voltage and current are not always in phase. Power in an AC circuit is the rate at which energy is transferred. But unlike DC, we focus on something called average power because AC is constantly changing. So the formula is power P is equal to RMS voltage multiplied by RMS current multiplied by cos phi. RMS voltage is the effective voltage. RMS current is the effective current. Phi is the phase angle between voltage and current. Cos phi is what we call the power factor. It tells us how efficiently electrical power is being used. RMS values are just a way of converting AC into an equivalent DC value. RMS voltage is equal to V0 over square root of 2. RMS current is equal to I0 over square root of 2. So anytime you say RMS, it actually means the effective value. Types of power. In AC circuits, we actually have three types of power. 1. Real power P. This is the useful power, the one that does actual work, the average power. Power is equal to RMS voltage multiplied by RMS current, measured in watts. Examples: lighting a bulb, heating a coil. 2. Reactive power Q. This is the power that moves back and forth between the source and the component, like inductors and capacitors. Reactive power Q is equal to RMS voltage multiplied by RMS current multiplied by sine phi, measured in volt ampere reactive. It doesn't do useful work, but is still important. 3. Apparent power S. This is the total power supplied by the source. Apparent power S is equal to RMS voltage multiplied by RMS current. Is measured in volt ampere. Power triangle. Imagine a triangle. The base is the real power P, the height is the reactive power Q, and the hypotenuse is the apparent power S. S is equal to P square plus Q square or square root. And from this triangle, cos phi is equal to P over S. Sin phi is equal to Q over S. For pure resistor, when the circuit has only a resistor where voltage and current are in phase, phi is equal to 0 degrees. Therefore, P is equal to RMS voltage multiplied by RMS current. All power is used. For pure inductor or capacitor, when it's only an inductor or capacitor, phi is equal to 90 degrees. No power is actually consumed. Energy is just stored and returned. The power factor cos phi is equal to R over Z. So the closer it is to 1, the more efficient your system is. Let's quickly recap. Real power, useful watts. Reactive power, stored energy. Apparent power, total power supplied. And in the next video, we will look at how this applies to real-life electrical system. Example: a circuit is connected to an AC supply. The RMS voltage is 120 volts, the RMS current is 5 ampere, and the phase angle between them is 60 degrees. Find 1. The real power P. 2. The reactive power Q. 3. The apparent power S. First step in any physics problem, write your given values. RMS voltage 120 volts, RMS current 5 ampere, phi is equal to 60 degrees. Let's start with apparent power, the simplest one. Apparent power S is equal to voltage multiplied by current, the RMS values. S therefore is equal to 120 times 5. S is equal to 600 volts ampere. So the apparent power is 600 volts ampere. Real power P. Let's calculate the useful power. Power P is equal to RMS voltage multiplied by RMS current multiplied by cos phi. We know that cos 60 degrees is equal to 0.5. Substitute the values. P is equal to 120 times 5 times 0.5. P is equal to 300 watts. So the real power is 300 watts. Reactive power Q. Now the power that moves back and forth. Q is equal to RMS voltage multiplied by RMS current multiplied by sine phi. Sine 60 is approximately 0.866. Substitute the values. Q is equal to 120 times 5 times 0.866. Q is equal to 519.6 volts ampere reactive. So the reactive power is approximately 520 volts ampere reactive. Let's confirm this using the power triangle. S is equal to P squared plus Q squared or square root. Substitute for P and Q. S will become 300 square plus 520 square or square root. S is approximately 600 volt ampere. If this helped you understand AC power better, don't forget to like, share, and subscribe. Bye.